Let's take a look at the answers to our N7.3 SCMA Fractions and Decimal Test practice. This is actually the practice here. All right, question number 1. Write each division statement as a fraction and then divide, leaving your answer as a decimal. Now this part is optional if you know the decimal rate off. So we've got 25 divided by 100. Well, that's 25 over 100. What is that as a decimal? Well, you should know this automatically, that 25 divided by 100 is 0.25. Make sure when you're writing your decimals that you make them nice and big and obvious to see. 3 divided by 10. Well, as a fraction, that's 3 over 10. And as a decimal, that's 0.3. All right, the last one now, on the bottom. 4 divided by 12. Well, that is 4 divided by 12. Now I can reduce this fraction. Divide by 4, divide by 4, and I'm going to get 1 divided by 3. Now, to do my division, 3 goes into 1.000. 3 goes into 1 0 times. Get a 0 there. That's a 1. Bring down the 0. That's 10. 3. That's 9. Subtract 1. Bring down the 0. 0.3 with a repeating 3. 0.3 with a repeating 3. Now you can put a bar over the 3 or a dot. That's the first page. Second page. Which of the following numbers has been placed incorrectly on the following number line? Explain your answer. Well, I'm looking at 9 over 16. 9 over 16 is close to 1/2, so it looks to be about right. 7 over 4. 7 over 4, well, that is 1 whole and 3/4. So it's 1 whole, and then it should be 3/4. Well, this one should be kind of over here, actually. But let's look at 11 over 10. 11 over 10. That's equal to 1 whole 10 and 1/10. That's bigger than 1. Right, this is bigger than 1. And on here, it's lower than 1 on our benchmark. You can see 1 right here. So this one should definitely needs to go over here. This is the one that is wrong. Completely wrong. Wrong. No, it's wrong. It's a good thing I can spell. I mean, 7 over 4 is wrong too, but this is the one that's really wrong. It's on the wrong spot relative to the benchmark given. All right, let's place all the following numbers in order from least to greatest. Okay, so I've got some decimals and fractions. I'm going to turn the fractions into decimals. Does that make sense? And then I can compare them easily. Like, I know that 0.65 is my smallest so far, but I want to check on these. So 6 over 8 is equal to 3 over 4. Then I can do that as a division question. That's 3 divided by 4. 0 decimal. That's 7, 28, 25, 20, 0. So 6 over 8 is 0.75. Okay. 7 over 4. Well, I put my 4 on the outside. Right, 7 divided by 4. So you just go like this. 7 goes into 4. 4 goes into 7 once. There's 1 whole. And we've got a 30, and that's 7, and that's 28, and that's 20. Bring down the 0, and that's 5, and that's 20. 0, 1.75. This is 1.75. All right, now I can order them. The 0.65 goes first, then 6 over 8, which is 0.75, then 1 whole, then 7 over 4, which is 1.75, and then 1.9. And there they are in the proper order. All right, next question. Krista placed the following numbers on a number line. She made several mistakes. Place the numbers in the correct order on the new number line. Yeah, like, I don't know, it's all over the place. This Krista, she's having some difficulties. So let's look at our smallest number. 1.112 is our smallest number. Well, not quite. 1 is our smallest number. And a little more than 2 is our biggest number. So let's put a 1 here. Let's identify our benchmarks. 1, 2, 3. Excuse me. So now the number 1 goes right here. Done that one. The number 2 is going to go right there. That's pretty easy. Done that one. Okay, 1.35, right? This would be 1.5, so 1.35 would be somewhere in here. 1.35. 1.112, that's smaller than this, right? Because the 1 is much smaller than 3. It's going to be close to this guy. 1.112. Now 1.66 is bigger than this benchmark of 1.5. So 1.66 would be somewhere over here. Done with that one. Then we've got 2.4 and 2.8. Oh, we did this one as well. 2.4, well, this would be 2.5, and 2.4 would be a little less than that, so it would be 2.4 right there. There would be 2.5, 2.6, 2.7, 2.8 would be much closer to 3. Done. This answer box is useless. So it's a matter of putting your benchmarks in the correct location and then organizing your numbers so that they're in the right spots relative to each other and the benchmarks. Number 5. Examine each fraction and its decimal equivalent. 36 over 99 is 0.363636. 54 over 99 is 0.545454. 63 over 99 is 0.363636, right? 2 repeating. Well, this one would be 77 over 99. It's 2 repeating like this. And what would be the decimal equivalent of 10 over 99, right? This 10 would be repeating. 0.1010 ... Or you could write it as 0.10 with a bar over those. All right, so indicate R for repeating or T for terminating. So remember, if we can get these guys out of like 10, 100, or 1,000, or 10,000, or 100,000, we can call them terminating. 7 over 8. Well, let's see. If I remember, I can divide this one. 8 goes on the outside, 7 goes on the inside, decimal 0, 0, 0. See if it repeats. 8 goes into 70 8 times to get 64. Subtract it 6, bring down the 0, that's 60. 7 times, that's 56. 40, bring down to 0. 5, 40, boom, stopped. Terminating. Terminated decimal. Let's look at the next one. I can make this one easily out of 100, right? Times it by 5, times it by 5. So it's equal to 65 out of 100, which is 0.65. Boom, terminated. 3 out of 5. I can make this guy out of 10. That's way easier, right? Times this by 2, times this by 2, now you get 6 out of 10. That's equal to 0.6. Boom, terminated. Surely one of these guys is going to repeat. Now we got a 6. I can't easily make 6 into like 100 or something, or 10. And I can't reduce this fraction. So let's try out our division. 6 goes into 5, decimal 0, 0, 0, 0. 6 goes into 5, 0. It goes into 50 8 times. That's 48. That's 2. Bring down the 0. 6 goes into 23 times. That's 18. Boom, 20. Bring down the 0. It's 3 again. Okay, so it's 0.8333. That's going to continue on. So, boom, repeating. All right. So either get them into fractions out of 100 and 10, 100 or 10 or 1,000, or divide them out to see if they terminate or repeat. The next one. The best 3 hitters on your baseball team had the following averages of 0.250, 0.288, and 0.340. Turn these batting averages into fractions. So 0.250, that's 250 out of 1,000. If you reduce that, you can reduce that to 25 out of 100, which then reduces down to 1 out of 4. This is the best answer. I will accept this answer as correct. This is the best answer, though. 288. Well, that's 288 over 1,000. Or 144 over 500. Cut them both in half. Or 72 over 250. Or, let's cut those both in half again, 36 over 125. And that's as low as it can go. Last one. 340 out of 1,000. Which would be 34 out of 100. Cut them both in half to get 17 over 50. I will accept these guys as answers, but know that these are the better answers. Number 8, observe this repeating decimal equivalent. So we've got 0.090909 is 1 over 11. 181818 is 2 over 11. 272727 is 3 over 11. So follow this pattern. What would be this guy? Well, look, this is 1 times 9. This is 2 times 9. This is 3 times 9. This is 8 times 9. So this would be 8 over 11. What would be the decimal equivalent for this guy? 5 over 11? Well, what's 5 times 11? 5 times 9? 54. So it would be 0.54, repeating 54. All right. Number 9. In a school with a population of 300 students, 192 students enjoy playing soccer. Use the number line below to show the population of students who enjoy playing soccer as a fraction of the school population. So our fraction is 192 out of 300. That's our fraction. Who enjoy playing soccer out of the school total. Now we got to put it on this number line somewhere between 0 and 1 whole. Right? The whole school doesn't enjoy playing soccer. 192 out of 300 do. So let's turn this into a decimal number to find out where it goes on here. To do that, I can divide this by 3 and I can divide this by 3. No, I can't divide this by 3 because that's, oh yeah, because right, 1 plus 9 is 10, 10 plus 2 is 12, that's divisible by 3. That makes this out of 100. Well, what's 192? How many times does 3 go into 192? We'll go 6 times, that's 64 out of 100. Well, that's equal to 0.64. Okay, let's label our benchmarks, right? We've got 0. This is 0.5, that's a half. This is 3/4, 0.75. This is 1/4, 0.25. So where would 0.64 go? Or 64% of the school enjoys this. Well, it's going to go between these two, right? And it's 10 away from this one, it's 11 away from this one and 14 away from this one. So it's a little closer to the 0.75, about there. 0.64. 64%. You can think of this as percent, right? 0, 25%, 50%, 75%, 100%. 64% right there. All right, on to the last page. The library before school breaks is very busy. Before Christmas, 150 students visited the library. 84 of them signed out books. Before Easter, 160 students visited the library. 96 students signed out books. Use the number line below to show which break had a greater fraction of students sign out books. So the first one was 84 out of 150. This is Christmas. And then Easter was 96 out of 160. All right, now we've got to compare these fractions. They're big numbers, though. Let's break them down a little bit. Let's see if we can. Boy, here's hoping. So I don't have to do all the division for this one. So the first guy. This is equal to 42 out of 75. That's not really helpful. The second one, I just have cut it in half, is equal to something out of 80. Divide them both by 2. 48 out of 80. This one's going to be a real pain in the butt. This one's not going to be a real pain in the butt. Let's divide it. 75 goes into 42 decimal 000. We only have to go about 2 decimal places. Well, it doesn't go into 42 at all. How many times does 75 go into 420? Well, 75 is a pretty easy number to work with. I'm going to write out some 75, 150, then 150 plus 75 is 225, then it's 300, 375, 425, 500. It's a good pattern. It's pretty easy. Well, that one doesn't work. That one works. That's 1, 2, 3, 4, 5. That's 5. It's 375. Subtract. Cross, 10. That's 5. That's 11. 11 take away 7 is 4. We have 450. Now we're going to do 6, and that's 425. 25, 0, that's 250. That's going to be 3. That's 225. And that's going to be 25. And then we bring down 0. It's going to be repeating 3 right there. Oh, nice. That wasn't too bad. So 0.563 repeating 3. Let's look at the other guy. How many times does 80? Well, heck, I can reduce this one farther, right? This goes 24 into 40. That makes it easier. I can reduce even farther. 12 into 20. I can reduce even farther. 6 into 10. That's 0.6. This guy is 0.6. I just kept cutting them in half, cutting them in half, cutting them in half, and it worked out nicely. That's beautiful. I like that. All right, now let's put them on the number line. So we got 0 here. This will be 0.25. This will be 0.5. This will be 0.75. All right, let's see where they go. First one. This one's smaller, not by a lot. It'll go probably about here. 0.563 with a repeating 3. And this guy, 0.6, is just a little bit bigger. 0.6. Right? Because we look at our ones place value first, then we look at our tenths. The 6 is bigger than the 5. This is bigger. Not bad. All right, so using 1/4 equals 0.25 in the following representations, explain how fractions, decimals, and division are related. Well, first off, a fraction is a division question. That's number 1. So 1/4 is equal to 4 into 1 decimal 000. Right? The answer to this is a decimal. Right, on this one, what we have here is we have a hundredths grid, a 1/100ths grid divided into 4 parts. Right, because 4 equal parts. Of 25. Or 25 out of 100 is equal to 1/4, which is equal to 0.25. So all these things are related to each other. All right, that's it. That's the test practice. The test is going to be very similar to this. Make sure you have lots of space to show your work. And good luck on it.